Hello everyone. So let's do a few more problems on midpoint theorem and its converse. So before we start, let's quickly recap these two theorems. So what is midpoint theorem? So as per midpoint theorem, if in a triangle, if two midpoints are given, let's say the triangle is ABC and here D is the midpoint of AB and E is the midpoint of AC. Okay, then the line joining these two midpoints, will be parallel to BC. Also, DE will be equal to half of BC, right? This is your midpoint theorem. And what is the converse? So as per converse, in a triangle ABC, any one midpoint of any one of the side will be given. Okay, let's say D is the midpoint of AB. And through this midpoint, if there is a line which is parallel to BC, let's say, then this line will bisect the third side. It means E will be the midpoint of AC. I repeat, if in a triangle, if any one midpoint of a side is given, let's say here D is the midpoint of AB, and through D, if there is a line which is parallel to BC, through D we can see many lines can pass, right? Many lines can pass. But we are talking only about a line which is parallel to BC. Then the line DE will bisect the third side which is AC. It means E will be the midpoint of AC. This is the converse of midpoint theorem. So we will be using these two theorems to do some problems. So now let's get started. So I have taken this question from Concise Mathematics by Selena of grade 9. This is the 11th question of exercise 12a. So let's do this question. The question says in triangle ABC, P is the midpoint of side BC. So let's take triangle ABC. In a triangle ABC, P is the midpoint of side BC. So let's say P is the midpoint of side BC. A line through P and parallel to CA meets AB at point Q. So a line through P parallel to CA. This is CA. So from here you will draw a line parallel to CA. This line will meet AB at point Q. So this point is Q. Add a line through Q. Now through this point Q, a line through Q and parallel to BC. Through this point you have to draw a line parallel to BC. It means you will draw a line like this, right? This line is parallel to BC. Meets median AP at point R. So this is the median AP, correct? So this line meets median AP at R. This point is R. Now you have to prove that AP is equal to twice of AR. This AP is twice of AR, right? It means you have to show that R is the midpoint of AP. Okay, and also you have to show BC is equal to 4QR. So first we will write down what is given in the question. So here we can see that we will only write down what all important things are given in the question. So we can see that here P is the midpoint of BC, right? So BP is equal to PC. This is given. Then PQ is parallel to CA. PQ is parallel to CA. What else is given? QR is parallel to BC. QR is parallel to BC. That's all, right? Only these three things are given in the question. Okay. Now let's prove how AP is double of AR, right? So for this you have to show that R is the midpoint of AP, correct? Now, since you have to show R is the midpoint of AP, you will think how you can use the midpoint theorem or converse of midpoint theorem, right? So let's take triangle ABP because we have to show R is the midpoint of AP, right? So let's take triangle ABP. Now in this triangle thing, can you use midpoint theorem or converse of midpoint theorem? So see what all information are given in this triangle. So in this triangle, I know only one thing, that QR is parallel to BP. That's all. You can see here QR is parallel to BP. That's all. Okay, I have no idea about Q because there is no information. But if I show that Q is the midpoint of AB, if I can somehow show that Q is the midpoint of AB and QR is already parallel to BP, then from converse of midpoint theorem, I can say that even R is the midpoint of AB, and then this is done. This proof, this part is done, right? So now you have to think how to prove that Q is the midpoint of AB. So for that you will take triangle ABC. Now in triangle ABC, P is midpoint of BC. It is given, right? It is given here. You can see that it is given here. And through P, this line PQ is parallel to CA. Even this is also given, correct? So from converse of midpoint theorem, we can say that Q is the midpoint of AB, right? Now since we have shown that Q is the midpoint of AB, now in triangle ABP, in this triangle Q is the midpoint of AB and QR is parallel to BP. So from converse of midpoint theorem, we can say that R is the midpoint of AB. Okay, so let's write all these things. So first we will take triangle ABC. In triangle ABC, P is the midpoint of BC. This is given. PQ is parallel to CA. This is also given. This implies from the converse of midpoint theorem, Q will be the midpoint of BA. So from converse of midpoint theorem, you have to write down all these reasons. Okay. Now we will take which triangle? We will take triangle ABP. In triangle ABP, Q is the midpoint of AB. This we proved here. And QR is parallel to BP. This is given already, right? This implies R is the midpoint of AP from the converse of midpoint theorem. Okay. Now you have to show AP is equal to 2AR. How to show this? So what you can do is write AP is equal to AR plus RP, correct? Now we have shown that AR is equal to RP, correct? So here I need AP and AR. So I will replace RP with AR, okay? So AP is equal to AR plus RP I will replace with AR. So this gives me AP is equal to twice of AR. So this is what we had to prove. So hence proved. I hope it is clear to everyone. Let's quickly recap. So what we have done, we have taken triangle ABC. Here P is the midpoint of BC and PQ is parallel to CA. This implies even Q is the midpoint of AB, right? Now in triangle ABP, in this triangle Q is the midpoint of AB, proved above, and QR is parallel to BP. This implies even R will be midpoint of AP from the converse of midpoint theorem. So this shows that AP is twice of AR. Okay. Now let's prove the second part. Yeah, now we have to show that BC is 4 times of QR. Okay, so can I write BC as BP plus PC? BC as BP plus PC, right? Now, P is the midpoint of BC. So BP is equal to PC. So can I replace this PC with BP? Reason, BP is equal to PC. So this will be equal to 2 times BP. Correct? Now, see, you have to keep an eye here that you want relation between BC and QR. Okay, so here BC is equal to 2 BP. Now I have to think how to convert this BP into QR. So now check what is the relation between BP and QR. BP and QR, these two. So in triangle ABP, we know that Q and R, they are the midpoints of AB and AP. Therefore, from the midpoint theorem, we can say that QR will be equal to half of BP, or you can say BP will be double of QR. Correct? So can I write down this BP is double of QR, twice of QR? Reason, from midpoint theorem, right? So this will be equal to 4QR. So BC is equal to 4QR and hence proved. Okay, so once again I repeat what we have done. First you have to take BC. BC is equal to BP plus PC, because P is the midpoint, it's given already. So here PC I replaced with BP. PC I have replaced with BP. So I get BC is equal to twice of BP. Now how BP and QR are related, that you have to check. BP is double of QR. We have applied midpoint theorem in triangle ABP, right? So I replaced BP with twice of QR. So BC is equal to 4QR. Now I have taken the 13th problem. So this says that in a triangle ABC, AD is a median. Let's take triangle ABC. So here AD is a median. So AD, you all know what is median, right? This will be the midpoint of BC. Basically BD will be equal to DC. And E is midpoint of median AD. So here E is the midpoint of median AD. A line through B and E. So we have to draw a line passing through B and E. This line meets AC at F. Okay, this is a straight line. Yes. So a line through B and E meets AC at F. Now we have to prove that AC is 3 times AF. Okay, it means what? That obviously this line AC is getting trisected, right? So for that you have to construct a line parallel from D. Let's say this is DE. So DE is parallel to BF. Now you can see the line is, if you show that the line is getting trisected, it becomes very easy to show that AC is 3 times AF. Okay, so let's first write down what is given here. So triangle ABC is there. Triangle ABC. D is the midpoint. Let's write BD is equal to DC. So BD is equal to DC. Also E is the midpoint of AD. So AE is equal to ED. What else is given? That's all, right? Now, what do you have to prove? you have to prove that AC is 3 times AF. So we have to construct DE parallel to BF. Okay. Now our aim is to show that AF is equal to FE is equal to EC. All these three parts are equal. Okay. Now E is the midpoint of BC, correct? And DE is parallel to BF, right? So we can see that in triangle CBF, we can take this triangle. In this triangle, D is the midpoint of BC and DE is parallel to BF. So what can you conclude? From the converse of midpoint theorem, we can conclude that even E is the midpoint of FC, right? Let's write this much first. So in triangle in triangle BCF, in triangle BCF, in this triangle, what do we see? That D is the midpoint of BC and DE is parallel to BF, correct? This implies that E is the midpoint of FC. Alright, from converse of midpoint theorem. So this implies FE is equal to EC. Let's name it 1. Alright. Now, after this, once again you see what is given, because this given is like a hint. This will help you to proceed in the question. Now we know that again AE is equal to ED. E is the midpoint of AD, right? So let's take triangle ADE. Let's take this triangle. In this triangle, E is the midpoint of AD and EF is parallel to DE. So from the converse of midpoint theorem, again we can conclude that F is the midpoint of AE, right? So let's write down this. In triangle ADE, E is the midpoint of AD and EF is parallel to DE. This is by construction, okay? EF is parallel to DE. This implies F is the midpoint of AE from the converse of midpoint theorem. This implies AF is equal to FE. Let's say this is 2. Now from 1 and 2, what can you conclude? That AF is equal to FE is equal to EC, right? Now we have to show what AC is equal to 3 times AF. So how do we present our answer? See, from this it is understood, right? But we have to, write and show. So we can write AC is equal to AF plus FE plus EC. Now all these three are equal to each other, right? You can see from here they are equal to each other. But I'm looking for AF, right? So I will replace these two with AF. So AC will be equal to AF plus AF plus AF, which is equal to 3AF, right? So hence proved. Let's quickly recap. So first I have taken triangle BCF. In this triangle, D is the midpoint of BC and DE is parallel to BF. This concludes that even E is the midpoint of FC from the converse of midpoint theorem, right? So FE is equal to EC. Now E is the midpoint of AD. So let's take triangle ADE. In this triangle, E is the midpoint of AD and EF is parallel to DE. So this concludes that even F is the midpoint of AE from the converse of midpoint theorem, right? So AF will be equal to FE. So finally we have shown that AF is equal to FE is equal to EC, right? So this implies that AC is equal to 3 times AF. This question is very simple. So this question says in triangle ABC, AD is the median. Okay, so let's take triangle ABC. So here AD is the median. It means BD is equal to DC. And DE drawn parallel to side BA. DE drawn parallel to side BA. It means you will draw like this. This is DE drawn parallel to side BA. Correct? Meets AC at point E. Meets AC at point E. Now you have to show that BE. So join BE. You have to show BE is also a median. It means you have to show that AE is equal to EC, or you can say E is the midpoint of AC. So this is a very simple problem. You can see that in triangle ABC, D is the midpoint of BC, it's given, and DE is parallel to BA, that is also given, right? So we can conclude that E is the midpoint of AC from the converse of midpoint theorem, right? So let's write down what is given in the question first. So triangle ABC is given where D is the midpoint of BC. So we can write down BD is equal to DC and DE is parallel to BA, right? DE is parallel to BA. Okay, these two things are given. Now what do you have to show? What do you have to prove? So you have to prove that BE is a median. BE is a median, which means that you have to show AE is equal to EC, or you can say E is the midpoint of AC, right? So it's a very simple problem. So here you can see that in triangle ABC, D is the midpoint of BC, it is given, correct? D is the midpoint of BC and DE is parallel to BA, this is also given. So what can you conclude from this? So we can conclude that even E is the midpoint of AC from the converse of midpoint theorem, right? So if E is the midpoint of AC, it means BE is the median. That's it. Okay, so let's write down. So in triangle ABC, D is the midpoint of BC and DE is parallel to BA. This implies E is the midpoint of AC. Okay, from the converse of midpoint theorem. This implies BE is the median. Hence proved. Now let's take this last problem. So here in the given figure, M is the midpoint of AB. You can see that M is the midpoint of AB and DE also. Okay, and N is the midpoint of BC and DF. N is the midpoint of BC and DF. And you have to show that EF is equal to AC. Okay, let's first write down what is given. So since M is the midpoint of AB and ED, we can say that EM is equal to MD and BM is equal to MA. Also, N is the midpoint of BC and DF. So I can write down BN is equal to NC and DN is equal to NF. Okay, this is also a very simple problem. So here you have to prove that EF is equal to AC. Okay, EF is equal to AC. Now here there will be a construction. You have to join MN. Okay, construction is now why we are constructing, you will get to know now. See, if we take triangle ABC, in this triangle, M is the midpoint of AB and N is the midpoint of BC, correct? So MN is the line joining the midpoints, right? So this line will be parallel to AC and it will be equal to half of AC, or you can say AC will be double of MN from midpoint theorem. Okay, so let's write down this. In triangle ABC, M and N are midpoints of AB and BC respectively. This implies MN will be equal to half of AC, or you can say that AC will be equal to double of MN. This is from midpoint theorem. Alright. Now, we have shown that AC is double of MN. Now, we will take the other triangle. In triangle EDF. In this triangle also, M is the midpoint of DE and N is the midpoint of DF. So again, we can conclude that the line joining the midpoints will be equal to half of DF, or EF will be equal to double of MN from the midpoint theorem. So let's write down this. This we can take it as 1. Now in triangle DEF, here M and N are midpoints of DE and DF, right? DF respectively. This implies MN will be equal to half of EF, or you can say EF is equal to double of MN. Let's say this is number 2. This is also from midpoint theorem. Okay. Now from 1 and 2, what do you notice? You can see that AC is equal to twice of MN. EF is also equal to twice of MN. So from 1 and 2, AC will be equal to EF. And this is what we had to prove, right? So from 1 and 2, AC is equal to EF. Hence proved. So quickly let's recap. First we took triangle ABC. In triangle ABC, M is the midpoint of AB, N is the midpoint of BC. So we showed that the line joining the midpoints will be equal to half of AC, or you can say AC will be equal to double of MN. AC is equal to double of MN, right? Same thing we showed in the triangle DEF. In this triangle, M is the midpoint of DE and N is the midpoint of DF. So the line joining the midpoints, that is MN, will be equal to half of EF, or you can say EF is double of MN. So we have shown that these two lines, they both are equal to double of the same line, which is MN. So they both has to be equal to each other, right? So it's done. I hope you all have understood these questions. These questions are really very simple. Only you have to understand the midpoint theorem and its converse. If these two theorems are clear in your mind, you can do any kind of problems. So that's it for today. I hope you like my videos. So please do like, share and subscribe my channel. So see you very soon in my next few videos. Until then, goodbye. Take care.